Hello students and my dear friends, Assalamu alaikum. You are watching NPTEL Chemistry E-class and I am your chemistry detective with solution of one new chemistry class 11th NCERT problem. So our problem is a sample of drinking water was found to be severely contaminated with chloroform. The level of contamination was 15 ppm by mass. Express this in percentage by mass. Determine the molality of chloroform in the water sample. Determine the molality of chloroform in the water sample. Let me make you understand our problem. In the problem, it is mentioned that sample of drinking water is contaminated with chloroform and chloroform is supposed to be carcinogenic, and level of contamination of this drinking water is also given 15 parts per million by mass in terms of mass. I mean concentration of this contaminant chloroform in this drinking water is given in terms of ppm and equals 15 ppm. Now we have to express this contamination, we have to express concentration of chloroform in sample of drinking water in terms of mass percentage. And in second part, we have to express this contamination in terms of molality of chloroform in the water sample. We can solve this numerical problem following two approaches, and in approach first, idea is idea is that you should first know what ppm is. ppm, mass percent, and molality. Parts per million, mass percentage, and molality. All these are methods. All these are methods of expressing concentration of solution. Parts, by parts per million we mean parts of solute present in million parts of solution, and if we consider that these parts are in terms of mass, then I will say mass of solute in grams present in million grams of solution. Parts of solute in million, 10 raised to power 6, million means 10 raised to power 6 parts of solution. These this part you can express in terms of mass or you can express in terms of volume, but here parts per million is in terms of mass. Second is mass percentage. Mass percentage means mass of solute. Mass of solute in 100 grams of solution. Because percent means 100, so we have to imagine that we have 100 grams of solution in total, and in 100 grams of solution we have to determine how much mass is contributed by solute. And last, molality of solution. Molality means number of moles of solute in 1 kg of solvent. I said that this numerical problem we can solve using two approaches, and in approach first I said that parts per million, mass percentage, molality, all these are methods of expressing concentration of solution, and in parts per million we report parts of solute present in million parts of solution. Parts can be either in terms of mass or in terms of volume. In mass percentage we report mass of solute in 100 grams of solution. In molality we report number of moles of solute in 1 kg of solvent. And one more idea I wish to convey to you, that solutions in which concentration of solute is expressed in parts per million, solutions in which solute is present in parts per million, these are very dilute solutions, and in dilute solutions weight of solution and weight of solvent are almost same, and volume of solution and volume of solvent are almost same. You can, instead of volume of solution you can take volume of solvent, instead of weight of solution you can take weight of solvent. And one more idea is that you know that you might be knowing that density of water is 1, therefore 1 liter of water means 1 kg of water, or 1000 milliliter of water means 1000 mg of 1000 grams of water. With these ideas I will now start solving this problem. First I will calculate mass percentage. It is given that 10 raised power 6 parts contain 10 raised power 6, because concentration in terms of ppm is given 15 ppm, it means 10 raised power 6 parts by mass of solution contain 15 parts. One part will contain 15 divided by 10 raised power 6. I am this time interested in calculating mass percentage. In order to determine mass percentage, I have to consider that we have total 100 parts of solution. Therefore, 100 parts will contain 15 divided by 10 raised power 6 multiplied by 100, and it will come equal to 1.5 into 10 raised power minus 3. This is mass percentage. Mass percentage of this contaminant in sample of drinking water, 1.5 into 10 raised power minus 3%. 100 grams of solution will contain 1.5 into 10 raised to power minus 3 grams of chloroform. Now second part we have to determine number of moles of solute in 1 kg of solvent. First we will calculate mass of solute in 1 kg of solvent. You see 100 grams contain 1.5 into 10 raised to power minus 3 grams. 1 gram will contain 1.5 into 10 raised to power minus 3 divided by 100. Now I will calculate mass of solute in 1000 grams of solvent, and then I will convert grams of solute in terms of moles. I will express grams in terms of moles. 1000, therefore 1000 grams will contain 1.5 into 10 raised to power minus 3 divided by 100 multiplied by 1000. It will come equal to 1.5 into 10 raised to power minus 2 grams. This is the mass of solute present in 1000 grams of solvent or 1000 grams of solution, because solution is dilute, very dilute, and mass of solvent will be equal to mass of solution. Mass of solvent can be taken equal to mass of solution. Now I will calculate number of moles. Number of moles will be equal to mass 1.5 into 10 raised to power minus 2 divided by its molar mass. Its molar mass of chloroform is 119.5, and on solving it will come equal to, it comes equal to 1 point moles comes equal to 1.25 into 10 raised to power minus 4. Given was 10 raised to power 6 grams of solution contain 15 grams of chloroform. I needed to calculate 100 grams of solution will contain how much grams of chloroform. This is grams of chloroform present in 100 grams of solution. Next I needed to calculate number of moles of chloroform in 1000 grams of solution. This is number of moles of solute present in 1000 grams of solution. But for calculation of this, I first calculate grams of solute present in 1000 grams of solution, and then I expressed grams of solute in terms of moles using formula that number of moles is equal to ratio of given mass by molar mass, and molar mass of chloroform is 119.5. Now approach second. I will use approach second now to solve this same problem. Approach second is in approach second you need to have idea that 1 ppm means 1 mg of solute in 1 liter of solution, 1 mg per liter. Remember this, 1 ppm is equal to 1 mg per liter. Therefore 15 ppm will be 15 ppm means 15 mg of solute of chloroform present in 1 liter of solution, and 1 liter of solution means 1 kg of solution, because solvent is water, and for water density is 1, so 1 liter means it's 1 kg. Now see, from here I will take this information that 1 liter or 1 kg or 1000 grams contain 15 mg of solute. 1 liter contains 15 into 10 raised power minus 3 grams. Instead of 1 liter I can write 1 kg because solution is dilute. Volume of solution can be taken equal to volume of solvent, and because solvent is water, its density is 1, it's 1 liter means it's 1 kg. 1 kg and 1 kg is equal to 1000 gram contains 15 into 10 raised power minus 3 grams. I will use this as base information for me. This is the basic information for me which I will use to calculate its mass percent and its molality. What is this information? Information is that 1000 grams of water contains 15 into 10 raised power minus 3 grams of chloroform. Now I will calculate how much. 1 gram first. 1 gram contains 15 into 10 raised power minus 3 divided by 1000. Now I will calculate 100 grams will contain 15 multiplied by 10 raised power minus 3 divided by 1000 multiplied by 100, and it will come equal to 1.5 into 10 raised power minus 3. 100 grams percent. In approach first I also calculated mass percent of chloroform is 1.5 into 10 raised power minus 3, and in approach second I also got that mass percent of chloroform is 1.5 into 10 raised power minus 3. Now I need to calculate molality. Remember that molality is equation of molality is this. Molality is equal to weight of solute multiplied by 1000 molar mass of solute multiplied by weight of solute in grams, weight of solvent in grams. W2 is weight of solute, here weight of chlorine. 1000 is M2 is molar mass of solute, that is molar mass of chlorine. W1 is weight of solvent in grams. Now identify what is given. Given is that 1000 weight of solvent is 1000 grams. W1 weight of solvent is 1000 grams, and 1000 grams contain 15 into 10 raised power minus 3 grams. W2 is also given 15 into 10 raised power minus 3 grams. W1 is also given 1000 grams. Molar mass of chloroform I know. I can easily now calculate molality. Molality will be equal to 15 into 10 raised power minus 3 multiplied by 1000 divided by 119.5 multiplied by 1000, and on evaluating you will get that molality is equal to 1.25 into 10 raised power minus 4. Same molality I got here. 1.25 into 10 raised power minus 4 moles are present in 1000 grams of solvent. Here also I got that 1.25 into 10 raised power minus 4 moles of solute are present in 1000 grams of solvent. If I may recall this numerical problem one time for you, in the problem it was conveyed to us that we got a sample of drinking water. It has contamination, and contamination is in form of chlorine, which is supposed to be carcinogenic, and concentration of chloroform in terms of parts per million was given 15 parts per million, 15 ppm. Now we have to express same concentration of chloroform in terms of mass percent and in terms of molality. First, I said that you should have idea that mass percent, parts per million, mass percent and molality, all these are methods of expressing concentration of solution, and by parts per million we mean parts of solute that are present in million parts, 10⁶ parts of solution. Parts you can express either in terms of mass or in terms of volume. Here parts were in terms of mass. So information given to us was that 15 grams of solute chloroform are present in 10⁶ grams of solution, and we used this information as base. We move to second step. In second step we had to calculate mass percent. Mass percent means mass of solute present in 100 grams of solution. As we know that 10⁶ grams of solution contain 15 grams of chloroform. I used unitary method. I calculated 1 gram will contain this much and 100 grams will contain 1.5 into 10⁻³ grams of chloroform. Therefore, mass percentage of this contaminated water, mass percentage of chloroform in this contaminated water, in this drinking water, is 1.5 into 10⁻³ That is 100 grams of sample of drinking water contains 1.5 into 10⁻³ grams of chloroform. Next we had to determine molality. I said molality is number of moles of solute in 1 kg or 1000 grams of solvent. Number of moles, not grams. Number of moles of solute in 1 kg or 1000 grams of solvent. I already knew. I said we will approach like this. We will first calculate grams of solute in 1000 grams of solvent, then I will convert grams of solute into molality using formula that molality is ratio of given mass and molar mass. I knew from mass percent, I knew 100 grams contain this many grams of chloroform. I used a unitary method. 1 gram will contain this, therefore 1000 grams will contain 1.5 into 10⁻² grams. But I needed to calculate moles, so I converted given mass of chloroform into moles using this formula. I got number of moles of chloroform is 1.25 into 10⁻⁴ present in 1000 grams or 1 kg of water. Next approach, I can use another approach in order to solve this problem, and in approach 2 I told you to remember this idea that 1 ppm means 1 mg, 1 milligram per liter. 1 ppm means 1 milligram of solute is present in 1 liter. Therefore, given 15 ppm will represent 15 milligrams of solute